Okay, in question 4, we're given this beautiful picture of a graph. We're given its equation. Okay, so underlining becomes very important. We've got the x-coordinate of the point A, and A is where it crosses the x-axis. So we've got an x-intercept, so that is a trigger method. For the x-intercept, we need to start with y equals 0. Okay, we've got an equation for the curve, so we solve for x. Okay, put y equals 0, solve the equation carefully for x, and you should get this first mark. Then it moves on to talking about curve D. Okay, and it gives you the equation of that, and it says on a copy of figure 1, so you have to make a copy of this. Now you don't actually need the graph that's shown for you there until you get to part C, but you will need it then. That's why it says on a copy of figure 1 rather than just do a sketch. So you make your own copy of the diagram. Then we've got to sketch this curve of D. All right, so it also tells me show the coordinates where the curve crosses the coordinate axes. So that's x-intercepts and y-intercepts. Okay, and here's the equation, and we can see that if we multiply this out, we're going to get x cubed. So it's a cubic graph. So for a cubic graph, the things you need to think about are shape, okay, x-intercepts, and y-intercepts, and the question's been very kind to tell us that we're interested in both the x-intercepts and the y-intercepts. And for the x-intercepts, as before, y is going to equal 0, and for the y-intercept, even easier, x equals 0. So the first thing you're going to do, is plug x equals 0 into that equation and see what value you get. Okay. But then the shape, you can see there's a positive coefficient of x cubed. Okay, so you know what shape to expect, but none of these things are going to get you credit until you actually draw them on your sketch. Okay, so it's vital on graph sketching things that having worked these things out, you show what you've worked out on a sketch, even if the other features of the sketch are wrong. If your y-intercept is x equals 0, then you're not going to get any marks unless you show a graph that does intersect the y-axis the y-intercept that you've calculated when x is 0. Unless it's shown on a sketch, you're not going to get any credit for it. Okay. This graph is all about the x-intercepts, and it's already factorized for you, so you're going to get actually 2 roots. So if you want this to equal 0, there's a possibility from the bracket, and then the x squared equaling 0 is actually going to give you a repeated root. And you need to remember that at a repeated root on a cubic graph, or any kind of graph, repeated roots give you either this or this kind of behavior. It just touches the x-axis at a repeated root. So the roots you get show the one for the repeated root here, show that in one of these 2 ways. All right, and make sure it looks the right shape for a cubic with a positive x cubed coefficient, and you should be there. Now part C, using your sketch, this is where you need to have the original graph on it as well as your new one, because we need to state the number of real solutions to this equation. So you have to look at this equation and see what's going on. Well, this side of the equation is the graph you've just sketched, y equals that, but the other side of the equation is what y equaled for the first graph that you were given a sketch of. So what you need to realize is that this is the equation you would get if you were solving this and this as simultaneous equations. So this is a trigger method backwards. Okay, you recognize this comes from simultaneous equations, and you know that simultaneous equations are what you would do for the intersections of 2 graphs. So if you have this picture with this graph on, and you've got another graph over the top, you have to look for how many intersections there are between the graphs, because that tells you how many roots there are. This is, if you were solving this, you'd be finding the points of intersection. So the number of solutions to this equation will give us the number of intersections there are between the graphs. So you look at how many intersections there are, you give that as the number of roots, but you won't get any marks unless you explain from your graph that you've looked at the intersections and you've counted those. Hope that helps.